Good evening, PostgresConf India. I'm Sujit Kuruvilla. I lead engineering for Azure database for Postgres. It has been an amazing day here, immersed in everything Postgres. Fantastic job by the PGConf organizing team for bringing us all here together for this wonderful event. At Microsoft, we love Postgres. We have been deeply engaged in contributions and efforts to the Postgres open source community, to the Postgres code, and with our product in the cloud. Let me touch upon quick updates on the latest on all these three. Number one, the community. We have been actively participating, giving talks, sharing, and learning from the community on all the major Postgres conference events worldwide. Out here at PGConf India, we have a great set of talks from our Microsoft team. POSIT stands for Postgres Open Source Ecosystem Talks, Training, and Education. It is a virtual event organized by the Microsoft Postgres team. It is scheduled for June 10th to 12th. The schedule just got published, so you can check out all the great talks that we have on the menu for you to pick from. Check out the QR code out there and stay tuned and take advantage of it. Talking Postgres is one of the three most popular Postgres talks out there. It is hosted by Claire Giordano, my Microsoft colleague and Postgres contributor. She's right here with us. Claire has been giving this talk. It's at its 24th episode and counting, discussing the human side of Postgres databases and open source with an amazing list of guests on the podcast. You can check out this podcast at any of your favorite podcast apps. We do have a Microsoft booth right outside. Do stop by for any questions, info that you need, and we do have some free socks for you to take away. Now, moving on to number two, code. In Postgres 17, there were a total of 412 commits that were authored or co-authored by the Microsoft engineers. Async.io has been a long-running project. It's been led by Microsoft engineers. Andres Ruent kickstarted the project, and he continues to lead and guide those efforts. In addition to Async.io, there have been numerous improvements that were contributed to by the Microsoft engineers across the breadth and depth of the Postgres engine. Everything from vacuuming, memory performance, partition tables, and more. I will quickly touch upon two of the many contributions from the Microsoft team. Number one, I/O combining. In Postgres 17, the Async.io effort made a great step forward with the addition of the read stream interface. This is a screenshot from Postgres 16. Now in Postgres 16 and down-level versions, you can see on the left-hand side, I have the query that I'm running, and on the right-hand side is a strace output showing all the different system calls that Postgres is making. You can see that every read is a 8K page I/O read from the disk. With Postgres 17, with the introduction of the read stream interface and its users, like the sequential scan, you can see I/O combining in action out here. You can see on the right-hand side of the screenshot that the I/Os are fewer in number, the I/Os are larger in size, and this is a great performance improvement. Number two, vacuum, wall reduction, and performance improvements. In Postgres 16, the wall log entries, the vacuum and freeze are distinct, two different entries. And moreover, the code in PG17 has been improved by bringing the vacuum and prune, the freeze and prune together, both improving the performance as well as reducing the val file size. You can see that the val file now has a single entry for the prune and freeze. Now a sneak peek into what's coming up in PG18. There have been improvements with multi-threading, Async.io, auth support is coming, vacuum enhancements, query planner improvements, and more. Now moving to the cloud. At Microsoft, we have been focused on two different user cohorts. One is enterprises, and number two is developers. The enterprise cohort is looking for promises on security, HADR, and scalability performance. These are the promises they require for their mission-critical workloads. When it comes to developers, they are looking for the latest versions of Postgres, the latest innovations from the community, and more recently, all the goodies on the AI front. We have been shipping features at a rapid clip in Azure database for Postgres. As these slides fly by, you can see that month over month, we have been shipping a great set of features and innovations. In October, we shipped the Elastic Clusters feature, which I will be touching upon. In January, we shipped the Disk ANN. I'll be covering the AI improvements and the advanced techniques towards the end of this talk. All these features, you can find the information on our blog, AKMS Azure Postgres blog, so check that out for more information. Now, Elastic Clusters is now available in Azure Database for Postgres. It is powered by the Citus extension. For folks who may not be familiar with Citus, it is a OSS extension that provides you the ability to scale out your database both in terms of throughput and in terms of size. With Citus, you get to add nodes, form a cluster that can be accessed using a single cluster endpoint from your application. It is a shared nothing architecture. It brings you the capabilities of distributed query planning, shard rebalancing, and all the other features you would expect from a distributed database. A very important thing about Citus is that it is a Postgres extension. It is not a fork. So which means that when you're using Citus, when you're using Elastic Clusters, you are using the native OSS Postgres under the covers. Now, there are two types of sharding that you can take advantage of in Elastic Clusters. If you have a multi-tenant application that already uses a database per schema type architecture, you can take advantage of schema-based sharding. It's an easy lift and shift, no schema changes required. Now, if you have a larger number of tenants, you may want to check out row-based sharding. It does involve some schema changes. You need to provide the shard key, which is important for Elastic Clusters to figure out how optimally to shard your data for maximizing your application performance. Now, a quick demo of the Elastic Clusters in action. Here, you can see that I have a 2-node cluster provisioned on the top pane and a 4-node cluster at the bottom. I'm running PG bench against both of these clusters. It is targeting port 7432, which is the Citus load balance port. You can see that the throughput that I'm getting on the 2-node cluster is 123K. The latency is around 2 milliseconds. With the 4-node cluster, I'm almost able to double my throughput to 205K and lower the latency to about 1.2 milliseconds. Now, Elastic Clusters gives you all the rich features that are available in Azure Database for Postgres. Business continuity, scalability, security, and manageability. Now, moving on to the second recent feature that we shipped that I said I will touch upon, AI for building intelligent applications. In this slide out here is the basic retrieval augmented generation architecture. I'm sure many of you are familiar with. AI is top of mind for many of you. The architecture depicts the chunking of the data, generating the embeddings, doing the vector search, feeding that to the Gen AI model, and generating the results that you're looking for. When we talk to customers, they aren't looking to add new capabilities to their Gen AI application. Their biggest challenge is to get the most improved accuracy in their existing Gen AI application. Now, the observation we have is that the large part of the challenges are in the information retrieval pipeline in this architecture. And I'll zoom in into this particular part of the architecture, share a few solutions, and advanced RAG techniques in the next few slides. First, the problem. Problem is twofold. One is of scale, and the second is of accuracy. The most popular vector indices out there, IBS flat, HNSW, they're memory-hungry algorithms. Memory is expensive. The larger your number of vectors, your costs increase significantly. DiskANN is an algorithm published in a paper from Microsoft Research. We have partnered with Microsoft Research to bring DiskANN into Azure Database for Postgres. It leverages a technique called quantization, where the vectors are compressed into a compressed vector with smaller number of dimensions. It runs the search in 2 stages. In the first stage, it runs against the compressed vectors, generates an initial candidate list. In the second stage, it pulls in the full fidelity, full dimension vectors and enhances the initial candidate list, providing you full fidelity, high accurate results at a lower memory cost and higher efficiency. The reduction in cost is about 4x, as you can see here on the slide. Now, moving to a demo where I will introduce a couple advanced RAG techniques. We have published this as a solution accelerator. Both the documentation and the code is available for you publicly for you to take advantage of. The demo scenario out here is a legal research copilot application. It is based off of a data set of US case laws. So all the different cases out there. The architecture diagram on the right comprises of a few different components that I'm going to go over in detail. The DiskANN is used for the vector search. Semantic ranking using the BGE re-ranker hosted in Azure ML. For folks not familiar with semantic re-ranking, it enables you to bubble up the most relevant search results to the top of your search. GraphRag from Microsoft is used for graph summarization. Apache Age PG extension is used for storing the graph. And the Azure AI extension provides a SQL-based interface to integrate with AI services. Now, let's dive into the demo. This is a chatbot, as I mentioned. I'm searching for a problem. Water is leaking into the apartment from the floor above, and I'm looking for legal precedents around this. Now, I get the answer. Now, I'm using vector search in this first particular example. I see that the second result is actually inaccurate. That's not the information that I'm looking for. Let's take a look at the graphical representation of the data set that is behind the scenes. So clicking on the graph button, you can see that the different bubbles out here, they represent the legal case. The larger the bubble, the more prevalent the cases. The golden color out here is very important. It represents that the legal case is part of a golden data set, which has been manually validated to be the precise results that we are looking for. The results returned by the vector search algorithm are circled in green. So you see out here that vector search, we got a recall of 40%, which means it only gave 4 out of the 10 correct results. Now, moving on to semantic ranker algorithm, the results get better. You see that the recall is 60%, and it is 6 out of the 10 results that it returned correctly. Now, switching over to GraphRag plus semantic ranker, both these advanced RAG techniques coming together, you can see that the recall improved further to 70%. 7 out of the golden data sets have been returned, and more importantly, the larger bubbles, the more relevant, prominent cases have been returned, and that's exactly what we are looking for. Now, back to the chatbot, you can see that the second result out there has been updated. This is a correct result that we were looking for, and important thing to point out, it actually lists the prominent legal cases as well. Now, taking a look at the queries that we are using behind the scenes for this demo, you can see that we are creating embeddings using the Azure OpenAI extension. Right there, you are able to do that within your Postgres query. We are taking advantage of semantic similarity search operation to do the comparisons. We are doing the semantic ranking using a UDF that we have provided as part of the solution accelerator, abstracting all the complexity of querying against the model in Azure ML and so on. So fairly simple. The results from the semantic ranker are then further filtered using the graph query. You can see the cipher query operation out there. It is counting the number of relationships for each of the nodes, which stands for the number of citations for a legal case, shows the prominence of the legal case, and hence using it to order the results, surfacing the most prominent legal cases to the very top. Now, another quick friendly reminder, we do have the free socks at our booth. Do check out, come by our booth for any questions, information that you have. We would love to hear your inputs on all the different Postgres things that we work on. Request 3 minutes of your time to take a quick survey. You can scan the QR code out there, and we have another pair of special stocks for you for doing that. So encourage everybody to click that QR code out there and share your input and feedback. And that's all I had. Thank you. Have a great rest of your the Postgres conference here. Enjoy. Thank you, everyone.